Hello everybody. Today I can find the probability of and or using P of A and B equals P of A plus P of B minus P of A or B, and P of A and B equals P of A times P of B. So there's a few different formulas that we're going to use in this lesson. And first of all, we're talking about the symbols here. We talked about these already, I believe. At least we talked about the and. The and is like a lowercase n, and the or is like a uppercase u. So there's three different formulas that we're going to be using today. Two of them are very, very, very similar. If it does not say anything about independence, we're going to use these two. Now these two are exactly the same formula, but when you're finding and, this one's or, and when you're finding or, this one's and. If you're given independent, then we use the and formula that we used in the independence lesson, which is P of A and B equals P of A times P of B. Take a picture of these, take a screenshot, write them down. You're going to refer to this throughout this entire lesson. And to help us remember this, we have a song. I believe you've heard it already, but you're going to hear it again now. I'll go to my YouTube channel, Math Schlansky. Hey, I got a new subscriber. I'm at 301. Fantastic. Playlists, Common Core Algebra 2 songs, and probability.
P of A or B equals P of A plus P of B minus P of A and B. P of A and B equals P of A plus P of B minus P of A or B. P of A and B equals P of A times P of B. Yeah, P of A equals P of A slash P independency.
Yeah. So the first two formulas, again, they're pretty much the same. If you're finding and, then this one is or. If you're finding or, then this one is and. If it does not say anything about independence, then those are the ones you're going to be using. If it does say that they're independent, then you're going to be using P of A and B equals P of A times P of B. Yeah. The second independence formula isn't going to really come up in this lesson, but we talked about in the independence lesson how we could use that. So we did a lot of talking, did a lot of singing. Now let's do some math. P of A equals 0.27, P of B equals 0.36, P of A and B equals 0.11. It wants the probability of A or B. Well, it doesn't say anything about independence, so I'm going to use my or formula. P of A or B equals P of A plus P of B minus P of A and B. So we're being asked for P of A or B. P of A is 0.27. P of B is 0.36. P of A and B is 0.11. Go to your calculator. Do 0.27 plus 0.36 minus 0.11. And I get 0.52, and that's it. It's just substituting into the formula. These are not given to you on your reference sheet, so you have to memorize them, and that's what the song is there for. Let's skip ahead to number 3. It's pretty much the same thing. It's asking for P of A and B. Does it say anything about independence? No. So P of A and B equals P of A plus P of B minus P of A or B. It's always the opposite. If you're finding and, this is or. If you're finding or, then this one's and. All right, whichever one you're finding, the other one goes at the end. I'm gonna let you try and do this on your own from here. Um, I'll just kind of hesitate. I'll just give you about 20 to 30-second head start and try and just substitute the values in. Again, it's asking for P of A and B. So you're just going to sub in P of A, sub in P of B, sub in P of A or B, and you'll have your answer. I'll give you about a 20-second head start. Okay. P of A, it says is 0.61. P of B, it says is 0.42. P of A or B, it says is 0.79. So 0.61 plus 0.42 minus 0.79 is 0.24. All right. Number 5. Number 5, it's asking for P of A and B. So let's just say that we try to do what we did before. P of A and B equals P of A plus P of B minus P of A or B. Do I have enough information to do this? No, I have P of A, I have P of B, but I would need P of A or B. I don't have enough information to do this. But it says that it's independent. If they're independent, then I use this formula. P of A and B equals P of A times P of B. Yeah. So P of A and B equals P of A is 0.25 times P of B is 0.12. So I go to my calculator, I do 0.25 times 0.12, and I get 0.03. That's it. They're not difficult questions. It's just knowing the formulas, knowing when to use which, and substituting in. Let's take a look at number 7. It says that they're independent. I'm dealing with and, so I'm going to do my independent formula. P of A and B equals P of A times P of B. Yeah. Now, it's not asking me for P of A and B like it did in the previous example. It's telling me that P of A and B is 0.25. It's telling me that 0.4 is P of A. It's asking me for P of B. So I'll call that X. So to solve for X, I do a little bit of algebra. I divide by 0.4. 0.25 divided by 0.4 is 0.625. And that's my answer. When you talk about independent, use the independent formula. And, they may ask you for P of A and B. They may ask you for P of A. They may ask you for P of B. You just put whatever values they give you into the appropriate spots. And if you need to, do the algebra from there. So now we're going to do the same thing, but we're just going to kind of start incorporating word problems into it. The probability of event A is 87%. The probability of event B is 70%. The probability of both is 60%. What is the probability of event A or event B? Well, for or, there's only one option. If I flip back, my formula for or is this one right here. P of A or B equals P of A. Let me get caught up. P of A or B equals P of A plus P of B minus P of A and B. It's asking for or. It's a very small word, or, but it's a very important word. Whenever you see or, we know to use the or formula. Now, you might be saying, well, Mr. Schlansky, do I make the percent into decimals or not? It doesn't matter. It really just doesn't matter. I'm going to make them into decimals. Just this way we're consistent. In general, whenever we see percents, we make them into decimals. So why don't we just stay consistent with that? P of A is 0.87. P of B is 0.70. Both events, well, both means A and B. So that's your P of A and B is 0.6. You can use a calculator if you need to. Again, you do not need to convert them to decimals in this particular problem. It's not wrong to. But in this course in general, you want to convert them to decimals. That's why I did it. And I get 0.97. And that's it. I don't feel we need to go over that one. I guess we can take a look at 11. Events A and B are independent of each other. If they're independent of each other, then I know that I'm going to be using the independent formula. P of A and B equals P of A times P of B. Yeah. I want you to try it on your own from here. So please pause, try number 11 on your own, and then unpause. Okay, now that you tried number 11 on your own, the probability of event A happening is 10%. So P of A is 0.10. The probability of event B happening is 0.28. That's P of B. It's asking for and. You can put an X or you can just write P of A and B. It doesn't matter. So I just do 0.10 times 0.28. And I get 0.028. If you wanted to put your answer as a percent, there's no need to, but if you wanted to make that back into a percent, you would multiply it by 100. If it's multiple choice, you might see your answer written either way. Whoops. I got an extra 0 in there. Times 100 is 2.8%. And again, you don't have to do that. Either one of these is fine. All right. 13. The probability that a student in Jaqua High School is in band is 127 over 466. The probability that a student is on the track team is 82 over 460. You know what? Let's not do this one. Let's do one that's a little bit harder. Yeah. The probability that a person files their tax return in March is 127 over 165. The probability that a person watches college basketball in March is 98 over 123. It's a little bit wordy, but it is what it is. If the probability that a person watches college basketball and files their tax return in March is 62 over 95, what is the probability that a person watches college basketball or files their tax return? It's a lot of words here. Keyword, or. P of A or B equals P of A plus P of B minus P of A and B. It's asking for P of A or B. P of A, so let's let A be their tax return and let B be college basketball. So P of A is the probability that they file their tax return. That's 127 over 165. P of B is basketball. That's 98 over 123. And P of A and B would be both their tax return and their college basketball. That's 62 over 95. For those of you who are afraid of fractions, well, it's a good thing you have a calculator. If you're afraid of fractions and you don't have a calculator for some reason, well, that's a pretty poor choice. Alpha y equals enter 127 over 165 plus alpha y equals enter 98 over 123 minus alpha y equals enter 62 over 95. It wants the answer to the nearest percent, so I'll just kind of write 0.9138 dot 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 to make it into a percent, multiply it by 100. To the nearest percent is 91%. So there are, let me just take a peek. I don't think there's any more little twists here. Not really. So there's three formulas. If it does not say anything about independent, that's the longer one. It's P of A and B. There's one for P of, there's one for and, there's one for or. If it's and, you're subtracting the or. If it's or, you're subtracting the and. If it says that they're independent, then, and they wouldn't ask you about or with independent. If they ask you about independent, then you're using this one. So these are not given to you in the reference sheet for now. Have them written down and take a look at them. And to help memorize them, we have the song, which I played at the beginning. I'm not going to play it again now. Your classwork/homework is to finish probability of conjunctions and disjunctions. And conjunction is just the mathematical name for and statements, and disjunction is the one for or. So if you see it at the top of your paper, that's why. And hope everyone has a productive and a great day.